Okay, in this first example, we're going to find the volume of a solid generated by revolving the region bounded by the curve. This should say y equals x squared. The x-axis and the lines x equals 2 and x equals 5. And we're going to revolve that around the x-axis. So the first thing that I would do in this problem is just draw myself a quick little sketch of the region that we're revolving. We've got y equals x squared. Not the best parabola in the world. And the x-axis and the lines x equals 2 and x equals 5. And so we're revolving this region in here around the x-axis. Okay, so the first thing I'm going to do is look at a typical slice from this solid. And so we just cut a little slice out of the solid. And if we take that slice and draw the slice, it's going to look like a little disc, a very thin, short cylinder. And this distance, let me change colors here, this distance from the center to the curve, y equals x squared, is going to form the radius of this cylinder. And so the distance from here to here is x squared units. And therefore, the volume of a typical cylinder is going to be pi r squared h. The r here is the radius of the cylinder. And the h is the thickness, which in this case is going to be dx. And so that's the general formula for a volume of any of the slices that come from this solid. And so now we're just going to take that from x equals 2 to x equals 5, and we'll set up our integral. We've got the pi, we'll bring that out in front of the integral, times the integral from 2 to 5 of the radius squared times the thickness. And so we've got pi times the integral from 2 to 5 of x to the 4th. And at this point, we can make a decision. We can either integrate this by hand, or we can go ahead and use our graphing calculator and use the numerical integral to find this volume. But I'm just going to go ahead and integrate it by hand. This is going to be x to the 5th over 5, which we're going to evaluate from 2 to 5. And so we end up with, wow, 5 to the 5th over 5. That's going to be 5 times 5 is 25, times 5 is 125, times 5 is 625. And the last 5 cancels with the 5 in the denominator, so we end up with 625 pi minus 32 over 5 pi. And we can simplify that if we want to. It ends up being 3,125, 3,093 over 5 pi. And I'll just double check that, make sure I got that value correct. I'm going to go ahead and use my numerical integral feature and go ahead and do the numerical integral of x to the 4th with respect to x from 2 to 5, and I'm going to multiply that by pi. And I get 1943.389, which should be the same as what I got by hand. And it does match, and so I feel pretty good about my answer there. All right, that was your first example.